All right, well, I want to welcome everyone to radon and air monitoring across your projects. Before we get started, we always like to do a membership spotlight shout out to our members, ICCF Community Homes. They've been recognized by the Governor of Michigan in the Historic Preservation Awards 2023 for their Emerald Flats LEED Silver certified project renovation, breathing new life into this particular building. And, breathing new life into buildings, preserving buildings is a great start to reduce embodied carbon. And so we're excited to announce a new membership benefit with buildersforclimateaction.org, giving you 10% discounts on their BEAM embodied carbon training. So you can check that out, become a member, get that discount, and help reduce carbon. All right, so before we get into our session here, radon and air monitoring across your projects, I want to give a shout out to our top tier sponsor of this session, April Air. They're going to help your clients stay healthy, humidity control, temperature control, air purity. They have water efficient humidification system, which is a win for water and energy conservation in the winter. Energy efficient dehumidification, which can be paired with a right sized heat pump to keep cooling and keep your cooling system at a higher set point. MERV 13 filtration captures particulates of concern, such as growing airborne viruses, PM 2.5, wildfire smoke, VOCs, dust, and more. And on today's topic, once you determine and monitor your radon, which is what we're going to be talking about, and determine that there may be a concern, or whether you're building new and just want to avoid it from the start, April Air has the systems that can help you reduce radon and mitigate that, whether you're new construction or retrofit projects. So check that out over at aprilair.com under their whole home products, radon mitigation. All right, so welcome again to radon and air monitoring across your projects. This session is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your education, your moderator. I am the education manager here at the GreenHome Institute, Brett Little, and this is our small team here. This course is approved for multiple continuing education units, as well as our certified Green Home Professional designation in health. AIA Health, Welfare, and Safety may make it applicable to your state-based design contractor license. And our good friends at Passive House Institute US, you can check for the code at the end of this session. Now, before we get into the session here on air and radon monitoring, we want to talk a little bit briefly about how radon is associated with the green building programs and what you need to know. So under the LEED for Homes certification program, the residential program, radon is addressed through radon-resistant construction practices. And so typically this involves requirements for homes in EPA Radon Zone 1, but then also you can get an extra credit if you do this in EPA Radon Zone 2. So you're talking about capillary breaks, you're talking about electrical outlets near the venting pipe for passive systems, you're talking about having the vertical vent pipe be properly installed with the T-fitting in the aggregate layer below. So we're not going to be talking about that today. We have other sessions we've done, and you can check that out as far as how to do these strategies. Canada also has some requirements here if you're doing a LEED project in Canada that you can take a look at as far as testing procedures. Now, for those of you outside of the US, in countries with, especially with no radon practices, there's a couple different strategies you can take. First of all, the one that we recommend, and we recommend this in the US too, is just assume the worst. Assume a high-risk radon system and install the passive ventilation system and encourage testing. If you do not install the system, then we're talking about long-term tests or short-term tests. And again, today we're going to be talking about these long-term tests and the best way to do it that have things beyond benefits to your clients for radon, right? And so, or you can demonstrate that the project is in a radon low zone by having government available data in those other countries. Now, if you're doing a LEED renovation project, again, if the building is an EPA zone with no zone 1 with no slab work being done, then you need to test the building for radon. So again, we're going to be talking about that today. What is the best way to test? There's a good, better, best approach. This is the best way to do it, more long-term, and ensuring that anything changes. So again, it's above and beyond the requirements for LEED, but it is something we are going to be highly recommending. And this is what needs to be done when you're doing renovations. Now, for the Green Star certification program, if you're following that program, whether it's new or existing construction, if you're in an EPA radon zone, you do need to put in a mitigation strategy. But all homes, no matter what zone they're in and no matter what new or existing, must do testing. Because, and here's what we have found in practice, we've been going around testing existing homes, even in radon zone 3s, that come back high off the charts. We saw someone's house come back, at 25. Again, 4 is the level where you take action. Other countries take action at 2. So again, this person happened to be a nuclear submarine operator, so maybe it was radiating off this person. But anyway, I don't know. But we see these things come back at higher levels. So the Green Star program is requiring, no matter what zone you're in, to do the testing. And so if you want, there's some alternative approaches and some higher level approaches in the gold level of Green Star to require ongoing permanent testing, which is what we're going to be talking about today. So with that, I will end and I will hand it off formally to our speaker here, Kai with Sun Radon. Kai, please join us and take it away.
Good morning, everybody. Thank you, Brett, for the introduction and the nice introduction to the entire topic. I hope everybody can hear me well. If not, please let me know. I will share my screen. One second here. All right. I hope everybody can see my screen now. We're ready to go.
Yep, all set. Thanks.
All righty. So as Brett said, the talk today is about radon in the air monitoring across projects and what does it mean. So as an introduction, just really quick to myself and our company here. My name is Kai Wundke. I'm the CEO of Sun Radon, a Melbourne, Florida-based company, privately owned, and we are doing design, manufacturing, and service of radon indoor air quality monitors since more than 30 years, actually since 1985. And we're serving professional radon testers, home inspectors, as well as consumers or any other facility managers, property managers, landlords, you name it. As I said, we invented the first digital radon monitor in 1987, and since then we've been trying to improve our products and our services. And since that time, we deployed tens of thousands of units, which are still in the field and monitoring. And every day or every year, we collect tens, if not 100 millions hours of data, which help us make decisions. And also, this presentation is based on. This presentation is purely based on our experience, what we see, and what we do from a manufacturing perspective to help improving indoor air quality. Quick agenda to my talk. First, I know a lot of you probably are very well aware of what indoor air quality means, but I'd like to give a short introduction to that again, to bring it into perspective. Indoor air quality, why does it matter and how does radon play into that? I will repeat also what is actually radon. Not everybody, I cannot assume everybody knows what radon is and what the dangers of radon are, and then I will go into the testing strategies as well as some examples of modern IoT-enabled monitoring systems for radon as well as indoor air quality, and a short summary at the end. If I talk too fast, please let me know. Also, if you have questions, you can use the chat and ask Laura, and if we can also have a Q&A session at the end. Now, to my first point, what is actually indoor air quality and why does it matter? If you look at the definition from the EPA, it's a pretty simple definition. It's basically any air quality within or around buildings or structures, especially as it relates to health and comfort. So it's not just about your health, but also about your comfort of buildings. Now, if you look indoor versus outdoor air quality, We all know a lot of climate changes happening outdoors based on our fuel, burning fuels, and most of the outer air pollutants, the top 5, 3 out of them are related to fuel burning. This nitrogen dioxide, sulfur dioxide, carbon monoxide. But then, of course, we have ozone layer, and particulate matter, all size of dust, of pollution. Now, if you look in the indoor environment, you technically can have exactly the same pollutants indoors. Of course, there are filters, there are HVAC filters, you don't just open the door and let it all in, but typically we have a good set of indoor particulate matters, a little bit different than outdoor, but it's still there, nitrogen dioxide and carbon monoxide. However, in the indoor air, we also have items which you're not worried about in the outdoor air. Part of it is because you're just not in touch with it, like asbestos, lead-based paints from the past, or formaldehyde, which is used in preservatives and manufacturing, or secondhand smoke. You're just not in contact with them. But then there are also gases, particularly radon and volatile organic compounds, or VOCs, which are actually also existing outdoors, but to a much, much lower level. Outdoors, the levels are so low that they're not dangerous to your health. If you go indoors, where everything is confined and where densities and concentrations can build up, all of a sudden this usually harmless gases outdoors become very, very, very dangerous to your health indoors. And because of that, if you look at the mix of the outdoor versus indoor air pollutants, it's not uncommon that your indoor air actually is 2 to 5 times more worse than your outdoor air. You don't recognize it immediately because you don't get immediately sick. And I will talk about that. Now, when we look at these trends, why indoor air becomes more and more of a concern, also something to do about this, as time goes on, we're spending actually more time indoors. And there are a couple of reasons for that. Part of it, of course, we all live at home in our homes, our apartments, but most of our work is indoors. Our offices are indoors, schools, hospitals, education facilities. In many ways, you can see that you can consider that for the most part of our life, we're actually moving from one indoor air facility to the next one and only spending very limited time outdoors. We all wish we would spend more time outdoors, but we don't. Because of that, items like the sick building syndrome, probably something that wasn't really a name 10, 20, 30 years ago, becomes increasingly a major occupational hazard. So if you read EPA and CDC guidelines and updates, you find a lot about the sick building syndrome, which is not a particular disease or illness or pollutant, but it's the combination of all this indoor air pollutants which basically make the sick building syndrome. Now, from our own experience over the last 3 years, we had our COVID-19 pandemic, and here policies changed how we work. We work from home much more than we work from our offices, actually. So it becomes more important as we go on that we spend more time indoors. On the other end, GreenHome Institute and many good organizations around have a lot of good initiatives about improving our building standards. Now, what this really means in many areas is we try to save energy. Yeah, try to have less pollution outdoors, but also less energy emanation from your house outside. And what this really does is, unfortunately, it prevents natural air exchange. Where maybe 100 or 200 years ago, there was a much more natural air exchange, simply even air conditioning, closed air conditionings weren't available as much. People open their windows. Today, almost nobody does it anymore, right? So we have improvements in the building standards from basements to walls, doors, windows, roofs. All of that drives energy efficiency as part of it. But also there are financial incentives to do that because you want to save money on burning energy. So you want to be green. It's all good. However, what this really means is that as we go on and spending more time indoors, at the same time, our houses become more insulated, more sealed up. Indoor ventilation and filtration play a much more important role in how we design our homes, how we design our commercial buildings, how we design our schools and educational buildings. And I give you statistics on the right side. If you look according to official research data, that kids spend average 9 hours in bed and 6 hours in school, all indoors. Now, when we talk about indoor air quality, just a really quick overview, what do you actually have here when you look at an average house? Now, there are some statistics on top which are just very alerting. One of them, again, you spend a lot of time indoors, but also 9 out of 10 houses show statistics have at least one indoor air quality problem. And it causes a lot of health issues. It causes health issues for kids like pneumonia, but also cancer, as I will show later. Now, when you look into your house, what can you have? You can have asbestos, lead, you're very familiar with it, but also radon from construction materials, from paints. You can have radon from your soil underneath the house, from the water. You can have toxins from candles. You can have VOCs from air fresheners, chemicals from furniture, and so on. You have mold and mildew or indoor air quality problems, particular bathrooms which are not ventilated properly, toiletries, cosmetics. You have cooking utensils, toxic chemicals from detergents, cleaning aerosols, and so on. So if you look at this really, if you're not careful, you have a lot of materials in the building of your house, the construction of your house, in the furniture, in what you use every day, in your utilities, in your utensils even, which could cause indoor air quality problems. And that's why it's so important. Now, good versus bad indoor air, what does it really mean? Well, I talked a lot about you want to prevent illnesses and diseases, such as cancer or anything related to more, but something maybe less obvious. You just want to breathe better, you want to sleep better, you want to have fewer allergies, you want to have just more energy. If your indoor air quality is good, these are the benefits, not just preventing diseases. On the other side, if the indoor air quality is not good, you can start anything from general discomfort. You have a headache, you have dizziness, shortness of breath. The next level up is you get infections, you get skin reactions, you get some poisoning, nausea, vomiting. And the next higher level is then you get you develop severe diseases, damages to your liver or kidney, to the brain and central nervous system, and up to cancer. Or it can be fatal. At the same time, the effect of indoor air quality is not just on your health, it's also in our society. If you look at your work, in your where you go every day, it affects productivity, it affects effectivity, it works. Statistics shows that there's a higher work absenteeism if the indoor air quality is not controlled in manufacturing and office environments. It reduces cognitive ability, so people are just not as well functioning if indoor air quality is not, I guarantee. Now, my last slide about the indoor air quality in general is also, I want to also talk about a little bit about the misunderstanding. Why are we where we are? Where not everybody is really very well aware of the danger of a bad indoor air. Number one is, typically when you talk about indoor air quality, you're talking about something that doesn't affect your life immediately. It doesn't kill you immediately like carbon monoxide or smoke. We have carbon monoxide detectors in our bedrooms. We have smoke detectors in our kitchens and living rooms. Yet we don't have any other air quality numbers because it doesn't feel like as urgent. There's some sort of complacency. The next point is that, interesting enough, a lot of indoor air pollutants are actually not easily filtered by your HVAC system. You think you have a good HVAC system, you have a HEPA filter, and there you have some advanced filtering, two-stage, you name it. Yet all what your HVAC system actually does is distributing your indoor air pollutants across the entire building. So there's also this false sense of security or safety that I'm good. Well, you might not be. The next point is some of the air pollutants absolutely do not show any early warning signs or side effects. So just because you don't have a headache, you don't sneeze, or you're kind of flapping around, doesn't mean you don't have a problem. Again, often false negatives give the false impression that no problem. And at the end, it was also not easy to test for all the indoor air pollutants until recently. Just until recently, technology like MEMS, which is a micro electromechanical systems, basically mini chips in one unit, which can measure for VOCs. It was just not as easy and available and affordable to test for indoor air quality and indoor air pollutants. It requires often you hire somebody very professional, somebody who can do a very specific test for you. Does a one-time test for a day, for 2 days, or whatever it is, gives you a report and you pay for it and you're good. This perceived cost and complexity is just not there anymore. No? So it's actually much easier. And at the end of the day, the indoor air quality effects can range from anything very simple as a slight discomfort. No? When you have high moisture, some people react to that, for instance, humidity, general wellness, but it can go all the way to debilitating diseases, including fatal diseases like cancer. And again, it comes down to, when you talk about indoor air quality, it's not just how well you feel in your comfort level. It can have very high severe impact on your house. Now, let's go to radon. So why radon? Obviously, radon is one of the #1 indoor air pollutants, and in our eyes, one of the most dangerous indoor air pollutants, and I will explain why. And what it is and what it does, I will explain as I go into radon testing. Now, some statistics here you might have seen before is, according to the EPA, some data from about 10 years ago, so I should be updated. About more than 20,000 people every day die from radon-induced lung cancer. And if you make this relative in numbers, it's actually more than drunk driving fatal accidents every year. It's more than all combined indoor home-related accidents, deaths, including fires, drowning, electrocution, falling from the ladder, you name it. You combine all this together, and it's still not the number of radon-induced lung cancer deaths every year in the United States. On the right side, you see some statistics, what the levels mean in terms of smoking. And also, just to visualize it, about 1 in 15 homes in the United States have elevated levels of radon. So millions of homes and schools and buildings are affected here. I also want to make a brief comment to the EPA zone. So Brett mentioned EPA zones 1, 2, 3 and requirements. I would like to put a little bit of a warning out there. These EPA zones are based on maps which are more than 20 years old. So we as a manufacturer, we are helping the CDC to basically update these maps. We're giving a lot of data to help looking at this, but these EPA maps are only, A, they're old, and B, they're only talking about known exposure from soil. They don't talk about what can happen based on local infrastructure, based on construction materials, none of that. So just because you're in the EPA zone 1 and not in the EPA zone 1, you can feel safe. Is also false conceptions there. Now, what is radon? Well, radon is a naturally occurring radioactive gas. Unfortunately, you cannot see it, you cannot smell it, and it exists everywhere. When I say everywhere there's soil, everywhere there's rock formation. It exists to a different degree, but it exists everywhere. On the outdoor level in the United States, or in the average everywhere, it's about 0.4 picocurie per liter. And I try intentionally not to go into technical details what this means, 0.4 picocurie per liter. But as radon emanates from the soil around all of us every day outdoors, it is there. Everybody breathes in, but at this levels, it's known below 0.5 picocurie per liter. Studies shows it has no long-term effect, no measurable long-term effect on your health. Now, radon can originate from soil under your home, but it can also originate from the water, which is basically polluted with radon, or it can actually, and many people forget that, come from construction materials. Very simple. If you use sand, which is radon rich, which emanates a lot of radon, and you make a concrete out of it, the concrete will emanate radon forever. Also not very much known is that radon actually can diffuse through a lot of the vapor barriers on the concrete material we think might prevent it from entering your home. Well, it might slow it down, but it actually doesn't prevent it. Now, there is, of course, if you have a steel wall, no radon comes through, and if you have a very dense concrete wall of 3 feet, nothing comes through. But often this is not the case. Often we think we have a plastic vapor barrier and you're protected. Well, we are not. Again, as I said, radon is in outdoor levels very low. Indoor levels, it starts to accumulate as it enters your home through the cracks, through diffusion, vapor barriers, diffusing through the diffusion vapor barriers. It accumulates in your home, and unfortunately, radon is one of the heaviest radioactive gases. It actually is heavier than air, and it accumulates in the lower lying room. It doesn't naturally disperse because it's lighter than air. It actually accumulates. It sits down and builds up more and more and more. And if you don't do anything about it, it just will build up. And the only way you get radon out is if you open the door or windows, if you don't do anything else. Now, again, radon is actually one of the things where you won't have any warning signs. You won't have any side effects. You won't know that you're actually inhaling radon every day and that it damages your lungs. And this is my last slide here. The dangers of radon is it gets into your home, as explained. You actually breathe it in, and what happens is you're breathing in the radon and it decays after you breathe it in. Once it decays, the alpha particle, which basically gets generated as part of this decay process, is actually what damages your lungs. And if you do that long enough, with the high enough concentration, slowly but surely changes the DNA of your lung, it basically damages your lung irreversible. And again, 21,000, and this number probably is higher by now, but it's basically the data we have from the EPA. Now, radon testing and monitoring. The core of this talk here is, what about the cost? And I have a quick one slide to that. And then type of testing, type of properties, type of long-term versus short-term testing, the question, why is long-term testing important? And then some examples about long-term testing with home monitors. Now, to the cost of radon testing. So, in average, a radon test costs you about $250. And when I say in average, so about what a radon inspector will charge for one test point when you have a single family home with one foundation. It's about what you pay for a device you can buy by yourself and install. So it's an average, but it's not much more than that. Now, if you want to test multiple homes, multiple floors, it becomes more. But per test is about $250. Now, if you find you have to mitigate, we saw from April Airs as Fred showed some mitigation system, which are basically fan system, active mitigation system for the most part. So it costs about $1,500 an average per system, per suction point for an active mitigation system. It's not insignificant. It's good money. But now, if you get sick, if you get cancer because of radon, well, the first thing is you have out-of-pocket expense for the insurance. If you have a good insurance, you might pay $4,000 a year. If you have a less good insurance, you might pay $30,000 out-of-pocket expenses. But the real cost really is in the tens of hundreds of thousands of dollars every year for cancer treatment. When you look radiation treatment, blood treatment, it goes up to almost $1 million a year per patient. Now, I don't even want to try to put a number on what is the cost of life when somebody dies because of cancer, or somebody actually missing family members, somebody just dealing with cancer, with the treatment of cancer, with the interruption of life, even if you're a lucky one and you can get treated and completely recover. I don't know how to put a number on that, but it's huge, and you can make your own judgment for that. If you look at it from an economic standpoint of view, the economic impact on the patients which get cancer every year. In 2019, the CDC estimated it was more than $21 billion. Then $21 billion economic impact, and radon is not just one of the second leading cancer for lung cancer, right behind smoking, is also very well in the top 7 of cancer in general, any cancer. Now testing. So I came up this slide by myself. You won't find this in any publication or anywhere, but I try to give a really high-level overview. When we talk about testing, what does it really mean? Or what options we have here? And so on the left side, you see this quadrant here, 4 quadrants, and I try to distinguish between owner-occupied facilities, buildings, and not owner-occupied. And what I mean is that is owner-occupied is all single-family homes, townhomes, owned apartments, condos, something like that. Something where you purchase it and you live in there. And this is what we have in mind when we talk about radon testing. Most people have that in mind. I buy a house, buy an apartment, condo where I live. I want to test. However, there's a much more larger number of structures available which are not owner-occupied, and we also need to think about it. And we spend time in there. Multifamily buildings, apartment buildings, rentals, basically rental buildings, office buildings, educational retirement facilities, your high school, your university, hospitals, commercial, industrial, manufacturing buildings. People spend 8 hours in a manufacturing floor making products for companies like us. It's indoors. We have to be concerned about that. Now, who are the responsible parties to make sure that this buildings and structures are safe to the occupants, to the people living there? So on the not owner-occupied sides of builders, there are landlords, property managers, facility managers, but then there are the occupants themselves who are responsible for their own action, for their own health. On the owner-occupied side, we have real estate agents, and I will talk about that in particular. Real estate agents, and then the owners itself, the sellers, the buyers of these properties who are responsible for that. Now, to the main part of the slide here is the coverage map. And when I say coverage, what I mean here is based on our experience, and those are not scientific data, based on our experience from having tens of thousands of devices out there, millions of hours of test data, what we see is when you look at the test coverage for radon. The largest test coverage is in the area of owner-occupied housing and short-term tests. So somebody who tests maybe for a day, for 2 days, maybe 7 days, but not longer than that. So there's a short-term test, and it's mostly facilitated in owner-occupied housing. Now, new regulations and awareness of radon in the air quality causes also more testing in not owner-occupied housing. This is this quadrant here, but the percentage of facilities and buildings and units, apartments covered by this testing is much, much smaller to the number actually which should be tested. So that's why it's yellow. Now, if you go to the next slide here, next slide, the long-term testing gets even smaller. Now, many homeowners become more aware of their indoor air quality in their home, and they might have had that an indoor air quality or radon test done when they bought a house. And some of them starting to make a long-term test. They're buying a long-term test kit, or they're buying an IoT device to do that. And this number is slowly but surely increasing, but it's by far too small. And even smaller is the number of tests done long-term and not owner-occupied buildings. I made it red here because it's really very rare occasion where you find a long-term test being performed in something in a building which is not owned by occupied by the owner. Now, from our perspective, what we would like to see from our experience, the impact on our health and what can be done, this is how the map should look like. There will always be short-term and long-term tests, because there's a practicality to that. And in many situations, when we talk about that, it's just not practical to test long-term for 30, 60, 90 days or continuously or 24/7. It's just not practical. So the short-term testing there will always be a need for that. And this should be the same need and the same coverage for not owner-occupied or owner-occupied. There shouldn't really be a difference. But the long-term testing coverage should be, I wouldn't say 100%, but it should be as large as possible, because there's no valid reason not to test. The cost of it and how to do it, the affordability, we are at a day and time now where this it's not an issue anymore. It should not be an issue anymore. Anybody can do it, and anybody at the end who's concerned can afford it. If you look at this, $250, you go out with your family of 4, probably two dinners you go out in a restaurant. That's what you skip 2 dinners in a restaurant out for 2 weeks, and you saved your money for an indoor test. Now, let's talk about owner-occupied testing first. Owner-occupied testing, so who's doing it? Well, for the most part, home inspectors, or home inspectors who are outsourcing, subcontracting radon testers, specific radon testers. And the majority of this testing is actually done during the initiated during the real estate transaction. If somebody buys or sells a condo, apartment, or home, when this basically gets initiated as part of the real estate transaction. It's because of that, it's time sensitive. Nobody wants to wait 30 days before you sign your contract and you move in your house. You won't have this passed. There will be contingency to radon test, but then you make a short-term test, 2 days, 3 days maximum. You get your test results, and you might have to install a mitigation system as a seller if levels come up high, but this is what triggers it. Now, so as I mentioned before, more and more as awareness goes up, there is some long-term testing performed by owners themselves, either if they are hiring long-term testing or they have long-term test kits, but for the most part, electronic devices, indoor air quality monitors like ours, are being more and more used for long-term testing by homeowners. And I think part of it is simply the radon awareness starts to help through social media, through internet, through talks like that. And white people test. Now, there's this noble concern about occupants' health, always. But to be honest, for the most part, you will see is the motivation to test is often not the occupant's health, but its liability and value, resale value. So what I mean is that as I mentioned during the home transaction, the real estate agent is actually responsible for helping to educate the buyer, making sure that they're aware of the danger when somebody buys a home, that it's been tested. There's contingency for mold, contingency for termites, contingency for inspections. More and more contingency for radon testing are being implemented. And the real estate agent is the conduit where this conversation happened during the transaction. Now, there's real estate agents are driven by deadlines. They want to close the deal. The seller want to close the deal. There's contingency you want to remove. The cost of testing mitigation is a concern and needs to happen fast. Okay? Now, more and more the responsibility shifts to the real estate agent. What I mean is that, as an example, over the last 2 years, there was a seller market, right? Home prices went up, interest rates were very low until recently. And what happened is there was bidding wars on the market. These are bidding wars where people try to get a house, and what they did is they waived contingencies, not knowing they shouldn't do that, not knowing better, trying to seal the deal. So went on, purchased the house, and what we see now actually in the industry is that there are more and more lawsuits now being filed by buyers who claim the real estate agent didn't act in their best interest. They didn't act responsible to educate them, to make them aware of radon and other indoor air quality problems to be tested before they build a home. So there's ongoing litigations there. You can Google it up. It's actually an increasing number now. And it comes down to, if radon is being done based on advice from real estate agent, comes down to the real estate agent's interests are he wants to protect himself, his liability, his exposure. Now, of course, you as a buyer, when you buy a home, you want to have a clean home. And as a clean, you want to have a clean in terms of indoor air, you want to have a healthy home, as healthy as possible. But you also recognize, just financially, you want to have a home you can resell, or if you have indoor air quality problems as time goes on and more of that becomes known, and maybe the next buyer tests for that, you don't want to have any surprises which might affect the resale value of your home. And then the next motivation is regulations. So unfortunately, there are actually no federal regulations which are applicable across all states. They're pretty inconsistent. Even so, in 1985, the EPA actually released the Indoor Air Quality Act, which basically a stipulated test for radon at the time, which started also our industry at the time. And that's when our company actually was founded in 1985. Now, since 2006, this EPA guidelines and the responsibility of the EPA actually shifted into proficiency programs, as they're called NIPP and NRSB. And these proficiency programs now provide testing certifications, that provide develop testing standards, and help us at basically replacing the role of the EPA there. But we also need to recognize, even if we do all these regulations, in some states are more advanced than others. It's estimated about 50% of our population lives in states where there's absolutely no testing requirement. So technically, you can make a real estate transaction, you can sell and buy your home, and never have to mention the word radon. Independent what zone you are, doesn't matter, 50% of US population. Now, if you go to not owner-occupied testing, who and how, typically is initiated as part of the construction, as part of a recertification of the building, of a renewal of occupancy certificates, things like that. If anything, when you have major reconstruction or building new constructions, this one basically just comes up. Again, it's time sensitive. And it's not necessarily time sensitive because during the construction, you wouldn't have enough time to test a long-term test, more than 7 days, 30 days, 90 days. It's because it's the lack of planning, the lack of awareness that radon is more, this testing is more like afterwards, where you want to make a check mark at the end of your construction project. You hire somebody for 2 days and you get it over with, you test it and you move on. So that's why it's mostly short-term testing, not because it cannot be done. Now, I need to say that testing large buildings requires planning. You cannot just, like a single family home where you might place one monitor. You do want a careful plan where you place your devices, where you make your test points, how long you test, how you analyze it based on environmental conditions, based on the ventilation in the building and so on. So it's not that easy, but it's also not that complicated. Again, we see a small uptick in testing for long-term testing here, again, mostly by vendors, not so much by occupants of commercial professional buildings, industrial buildings, mostly vendors who basically rent a condo, apartment, or home, and simply want to know. So they're installing some long-term testing. Now again, to the motivation, very similar here. If you look at the builder and the property managers and ours, yes, we would like to believe everybody has the noble concern about each other's health. And there's probably some truth to that. But at the end of the day, it comes down to liability and managing cost. And when I say liability, is if you, as a builder, if you test early and you have a certificate in hand or a report in hand which shows that you have done your due diligence, that this house is safe to occupy, you're free of, you cannot be claimed liable for changes later. Right? Also, it's cheaper to test early, and if you find an issue, to install a passive or active mitigation system while you're building the building or while you're planning to building the building, so versus fixing it later. Imagine an active mitigation system, as you've seen, is a plan with pipes. Or if you have a concrete building, apartment building, you have to drill holes through your concrete to make these pipes, which are not planned to be there in the first place. Or you have to drill holes into your foundation to have a suction point, right? If it wasn't planned to be there, it becomes just much more complicated. We see this every day from our customers giving us this feedback that the earlier you test, the easier and the cheaper and the faster it is also to do something about it. Now, the contra is builders and they are driven by deadlines. They're driven by trying to minimize the cost of testing and mitigation. Just a simple financial concern here. Similar for property owners, property managers, and landlords. Luckily for tenants laws become more and more strict and in the interest of the tenants. They provide more and more protection, and they add liability when not to test. So when not tested. But this means really is more and more what you see in these laws is if a property owner rents something out or office building and he doesn't test because he's not worried about it, and the tenant tests later and finds there's high levels, he can sue them. He can basically approach the property owner for liability claims. Just not knowing about it, not testing doesn't relieve your liability. So there's just this, again, it comes back to liability as a property owner. You want to test as early as possible. And of course, it's the best method. Now, on multifamily housing, just about last year, the HUD released new regulations starting rolling out with the FHA loan segment, so basically federal housing agency loans. Constructions built with these loans now have a much more strict requirement for testing. For new constructions, they also have now requirements for retesting old buildings, existing buildings. And there's actually a large backlog of testing. There's many thousands, millions of tests to be done based on this regulation change, which challenges the industry because right now, the preferred and only approved way to test is actually a short-term test versus a long-term test, which would be cheaper and easier to do. But that's where we are. Now, if you look at the banks and regulators, again, the banks who loan the money for the properties and the regulators, again, there's nothing consistent across all states. FHA adopted the first radon testing, and they're working right now discussing to expand it. We just had a session where it goes to the next level, FHFA loans. And again, 50%. We're talking about 50% of the population where there's no regulation whatsoever. Now, types of testing, short-term versus long-term testing. How I'm doing in time, Brad? I'm okay here?
Yeah, we're good. About 15 minutes. Thanks.
All right. Short-term versus long-term test. So short-term test, anything, I consider anything short-term test is not a hard definition, but practically is anything below 7 days. Basically something a professional can perform in a 2-day to 3-day test, typically 48 to 72 hours. And we need to recognize short-term tests relies on extrapolation to predict long-term results. Because of that, it's best performed by a professional who knows how to do this test properly so that you can extrapolate the long-term results. And that's why it must be performed under very well-controlled conditions to that these models of extrapolating actually works. And they're using certified equipment, which is calibrated, certified by the proficiency agencies to make sure that devices are using are actually giving proper results. And typically it's performed prior to occupancy or when occupancy changes or when a radon mitigation system was installed or updated. So that's why it's time sensitive. Now, long-term testing, which really evaluates the true risk of radon exposure, can be done by anybody. It can be done by the homeowner, but also can be done by professionals. It can be done by the builders, it can be done by the property managers, landlords. There's not much to it to do that actually. And more important to me is a long-term test is actually performed as an in-use condition. It's not performed in a condition which is artificial controlled to allow predictions of short-term results to long-term results. It is in an as-use condition, and this is the most relevant condition, how we live, how we work. And here, mostly for long-term testing, more and more we see actually what we call consumer-grade home radon monitors are being used for this testing. I will talk about that in a second. Now, why long-term testing for radon? Just emphasizing the point here. Why is it important? Why is a short-term test not good enough or not sufficient? It's good to start as a screening, but weather, it depends on the weather. And weather and seasonal change, the rain, snow, wind. You can imagine if your entire neighborhood is covered with snow, the radon cannot escape. It basically, snow is an insulation blanket. And the only way the radon can escape is actually through cracks in your home. So it accumulates in your home much more. Similar for air pressure, rain, very, very similar. So it changes on the season. It also changes when you do intended changes to your construction or around your buildings, or even in your neighbor's buildings, in the neighborhood. Remodeling, updates, construction, it all changes the potential exposures that radon actually can get into your structure, in your building, in your home. Or you have unintended changes. You have changes like settlement cracks. Your plastic diffusion barriers deteriorate, there are cracks, there are split, there get over, failure of insulation, seals and insulations. Now, all kinds of things you actually don't like to happen, but they do happen. And then we have system failures. We have mitigation systems which are intentionally installed, but motors and fans don't last forever. Sometimes we have piping blockage, something as simple as a bird building a nest on your pipe, and you don't recognize. Or electrical failures. Similar ventilation systems, which are a surrogate for mitigation systems, sometimes have the same type of issues, motor electrical blockage failures. So in short, basically, short-term testing is the fastest and easiest way to get a quick screening. But radon is a long-term problem. It's a problem in the lived-in conditions, and only long-term testing really can evaluate your true radon risk. Now, talking about how to test for radon long-term. So the good thing here is technology advances quickly. And it's not just us, Sunradon, there are also suppliers, vendors around, very good companies out there who are making very good products. The days of charcoal canisters, I would say, can be over, should be over. And there's a reason for that. The charcoal test kit, which you see a picture of, they're typically small canisters. You rip the label off, you put them in your environment you want to test. You put it in there for the duration intended, and then you send it into a lab. Costs you $25 per test. But if you want to have a long-term test, you either have to repeat the test many times or buy special test kits, and you get one number at the end. No? If you ask a professional to do the test, about $250 per test point. Or you buy a smart home monitor, which can be anything between $150 to $300 on average, let's say $250 per device. Now, the ease of use, the charcoal test kits, again, you have to actually manage them. You have to take the label off, you have to send them to the lab, and then they send you a result back. Smart home monitors, today, in today's age where you have a lot of smart appliances, smart devices in your home, you're controlling your light bulbs with your phone. Nothing different than a smart home monitor. You plug it in, you turn it on, you connect it to your mobile phone, you're done. Right? It's something we do every day now, which now becomes just our standard procedure of how we operate. Environmental conditions. Charcoal is a one-time use. It's actually, once it's used, it has to be disposed as hazardous waste. You're building mountains and mountains of hazardous waste using charcoal kits for decades. Smart home monitors can actually be used forever, and you actually can move from location to location. You can test for 90 days, 120 days, 6 months. You can move them to the next location if you feel secure and safe there. You don't have to stick to one location. And then the application. If you look at charcoal, you get one number, one time. There's no correlation to what's happened around this test. You just get a blind number. Smart home devices are smart, right? They can be installed by occupants, by owners. They can be professionally installed. They can be installed with remote monitoring capabilities where your professionals can now monitor and review your data remotely. They also monitor other conditions, temperature, pressure, humidity. They are monitoring what is the organic compound, CO2. No? So all in one concept, you have one smart device, which can give you really a total indoor air quality assessment. You can download data, you get trend analysis. If you have a spike, you can correlate what actually happened and correlate it to pan failure, let's say motor failure. No? And actually the mobile apps, more and more now you see out in the field, they help you what to do when you get high levels, what to do, who to contact, what to do, what's the next step. Now it guides you along the way. And what are the benefits? It's obvious. It's a true long-term test as an in-use condition. And The good thing is, because it's a continuous long-term test, it can detect sudden failures of systems, like I said before, mitigation system failure, but it can also detect very slow deterioration of your conditions. It's flexible, anybody can do it. It's accessible and connected. Most of them have now Bluetooth or Wi-Fi or more, or both. You have real-time access over Wi-Fi through the cloud and a mobile app. You have often web-based dashboards where for remote services, for facility managers, property managers, and it gives you actually more than just radon. It gives you more risk assessment, it gives you VC, CO2, outdoor air quality index, all these parameters you worry about, and you can be it all in one. And it's virtually maintenance free. Once you plug it in, there's nothing to do. You plug it in, you connect it, you're done. Now, again, I want to emphasize the home radon monitors are not intended to replace the professional short-term testing. There's always a place for that when time constraints are there, when conditions don't allow it to test for 90 days. However, they provide a really cost-effective, reliable, long-term solution for air quality assessment. And it's flexible. You can install them, you can use them as you need them. Now, let's go an example here. How does a modern, what I call IoT-enabled monitoring system looks like? On the left side, you see you have local users, which are basically homeowners, multifamily occupants, office users, managers, and so on. And what they actually do is they access that data through their mobile app. So they get automated alerts to their phone. So use their local Wi-Fi. So use Bluetooth for backup if they don't have Wi-Fi, for setting it up and as backup. And they can actually access the data through data download. So all of this you can maybe have. This could be different apartment buildings. This could be different homes. This could be different rooms within a manufacturing building. Doesn't really matter. You can make a network of this test, and they all at the end communicate through the local Wi-Fi to a cloud processing unit with a cloud backend, and then from the cloud processing unit back to the phone, where you can get your data anywhere, from anywhere and any time. You don't have to be next to the monitor. Now, anybody can do that, and technically you can have many monitors displayed or managed through your mobile app, but this becomes cumbersome as time goes on. If you have 100 monitors on your mobile phone for a facility manager, you don't want to manage your business through your phone. So what now modern systems have is they have a backend where the same data are now accessible by service providers as an optional feature. Again, this is more intended for property facility managers, landlords, or radon mitigation companies who install a radon mitigation system want to know if it actually works and provide a service guarantee, or general indoor air quality service providers. They now can, out of their office, out of their back office, they can now remotely monitor. They can set their own automated alarms, which are independent from what the user does here. So he can set his thresholds when he wants to get alert, when he wants to get a message sent that something needs to be done. Once he gets this managed, you have an integrated customer portal where you can directly use the same infrastructure. You directly contact back to your customer, say, hey, your radon level went up over the last week. Let us come by, stop by, and figure out what is going on. If it's just up for an hour, you don't have to do anything. So you can look at a trend. You can make decisions, database decisions, without ever having going back to the site. You can imagine if you have facilities, apartment buildings, or manufacturing facilities with tens or hundreds of these monitors, it becomes almost impractical to do that locally. You have the remote monitoring option now. Now, case study. I have just one case study here, and then some examples, and then I'm actually done with my talk here. The case study is a residential single-family home in Kansas. It's actually a true event. This customer of ours, he installed a long-term home radon monitor, and he detected high radon. He was surprised, kind of surprised, but he detected high radon. What he did is he hired a professional and confirmed the home monitor data with a short-term professional test. Tests were confirmed, and the active mitigation system was installed. Everything was good. However, what he also did is he kept the home monitor plugged in and connected and remotely monitored. And after a few months in operation, levels started rising quickly all of a sudden. And sure enough, when the mitigation company went back and looked at it, there was a fan failure. And here's some data to that. So how it looked like? It's a typical basement here with a suction pump. But the monitor actually plugged back in here. You see it's just connected to a power outlet and connected to Wi-Fi. And this is how it looked like before they mitigated. It wasn't super high, but certainly high to be very concerned about. remember the EPA guidelines is 4. This one was about 18, 19. Interesting enough also is it varies about a factor of 2 over this timeline. So this are, each data point is a 48-hour average. And you see how this 48-hour average goes up and down. So if you do just a short-term test, you might end up down here, or you might end up here. But this means both cases show elevated levels of radon. But as a mitigation company, you might design your system differently based on what you test. If you test down here or down here, right, up here. So it influences your design of the mitigation system. Now, once this customer installed the mitigation system, very quickly, once it gets installed, within basically 2 days, the levels drop below 1 picocurie per liter and stays there. You can basically immediately measure with your home monitor. You can manage through your mobile phone, or the mitigation company remotely. So I can actually, in real time, see if the mitigation system works or not. And if it doesn't work, something you can do about it. Now, you see mitigation system turned on and how it immediately goes down. It's just a different scale of the same chart. And here you see like how the system actually looked like outdoors. It's a pan installed with pipes, sucking up the radon from the lower level and exposing it above the roof line. Now, what happened is a couple of months later here, and we are automated monitoring via our remote cloud dashboard. The levels went up. Now we set the levels to 2 picocurie per liter as a warning level to do something before it goes above 4. And we received the warning quickly within, or yes, the system sent a warning within 24 hours of the failure. And when the investigation turned out to be a fan failure, so basically this fan was turned up. Now, you see again, immediately it's just a blown up different scale here. The moment the fan failure happens, you can see how it immediately rises and goes over the level. And you can set, we set the alarm with the yellow line, was the red, we didn't wait for that, or many people don't, shouldn't be. You can do something about it without ever having to go back to the site. So good thing also is the way the systems can be set up, that it actually averages over a 24, 48-hour period. What this helps is if you have a short-term increase, a short-term spike. It can happen for many reasons. Like in Florida, we never have radon in our homes, technically. But when a hurricane comes through pressure, we can see our radon levels come up for a day or two. Similar here, when you have snow, rain, you can basically distinguish short-term effects, which are not worried about your long-term health from long-term effects. And it's 24/7. You don't have to do anything. It's all automated. And you can basically do a remote failure detection without having to go back. In the very first slide from Brett, you've seen the April air system. Often today, what they do is deliver anemometers with the system or any pressure sensors which get installed into the pipes. And when the pressure goes down, it actually makes a beeping alarm. Now, this beeping alarm is only heard by the homeowner if he's lucky, if it's in the basement and knows what it is. Also, the anemometer, not everybody knows how to read an anemometer, but again, it requires a local interaction. Modern IoT-enabled home radar monitors don't require any of that. So, in my last slide here is some other examples of testing with long-term IoQ monitors. We call them IoQ monitors because some measure more than radon. There was a home in Florida. Florida is known for very low radon levels, and the reason for that is very sandy soil. It accumulates, it can basically emanate from anywhere on the soil and escape. It doesn't accumulate as much in homes, but it can when you have the right soil. But it also can, what it turned out to be, when you build your house with a concrete slab which uses sand from, like you in Florida, you're from Tampa. There's a big sand pit in Tampa, which is known for very high radon content in the sand. It's called francolite. So this is what happened here. I was very surprised. The owner actually, he ended up selling the house. Or we had a customer with a vacation rental. He installed it in a vacation system where he's not always there. Also, clients are not always there, and clients don't want to, when they go 2 weeks, 3 weeks on a vacation rental, they don't want to monitor for radon. So he does a remote monitoring with his mobile app, and sure enough, he found radon levels. He got actually not a radon alarm, he got a power line failure alarm. The system is plugged in a power line, and if the power goes up goes out after a couple of hours, you can set your alarm, and you get an alarm that the power's out, that you have to do something about it. Sure enough, the power was down for the radon fan, and before actually anything could happen, he actually went back with I think at the time with the rental and actually turned it back on. Simple thing, simple fix to a potential big problem. We also have facility testing by service providers. For instance, we have monitors installed not just for radon, but for instance, monitoring IT closets for humidity and temperature to make sure the very expensive IT equipment works properly. As a side effect, this customer, they are also provide feedback about the indoor air quality, in particular radon, to the property managers. So it's an indirect measurement, the benefit. One benefits the other. We are working with Georgia State University, who do greenfield, what I call greenfield testing. Basically, what they're trying to do with a government-funded project, they are build a network of monitors in greenfields in areas where there's supposed to be homes to be built. So I want to predict radon exposure and how severe they have to go about a radon system construction for these buildings. And by they're doing that, they're also collecting data about VOC and CO2 exposure and correlates it to environmental conditions. Now we also have classroom monitors. People use classroom monitors, in this case for churches. Here, the original intent was to monitor CO2 levels to detect basically overcrowding, overpopulation, or lack of ventilation. And as a side effect, I get VOC and radon monitoring as added benefit in insurance policy that not just CO2 is in its levels, but also radon and VOC. And at the end, just recently, we have actually some professional mold testing companies who are now using these monitors to build a mold risk indicator. We're using a model which is based on mold built up on wood to indicate the potential of developing mold in this environment. It doesn't measure mold itself. Basically, it gives you an analysis of how likely it is to develop mold. And this tester, basically, this professional uses the devices to test this now out, to install them and basically estimate potential mold risk. So you see there's a lot of variety, not just about radon, because we're talking about integrated systems which are easy to connect. You don't have to have special knowledge to install them. You're very familiar how to use your mobile phone, how you download a mobile phone app. You install it, you connect it. You can decide to either manage by yourself, or you share the data and have a service provider, an indoor air quality specialist, a radon specialist, the property manager, basically monitoring the data. And that's what gives me to my summary here is, I hope I could show you in the last 45 minutes that indoor air quality is important. Poor indoor air quality is a widespread problem. More than 90%, 9 out of 10 homes are affected. Radon, in our opinion, is one of the most dangerous pollutants because of you cannot detect it without a special detector for that. It has no side effects until it's too late, and it causes deaths. 21,000 deaths estimated. But it's easy to test. It's easy to test. It's a professional for short-term testing. I don't want to take this away. There's a need for that. But it's easy to test with long-term consumer products, which are now available at a very small price compared to the cost of radon-induced lung cancer and managing this illness or this disease. And then indoor air quality and radon awareness, it's increasing. You're seeing more people using long-term monitors, which is good, and we want to help with that. That's why we are here today. Progress is being made, but there's also a lot more to be done. There's a lot more to be done. Think about people who cannot, well, $250 is expensive. So I have to find this money now. We have to help them. And indoor air quality monitor becomes a value add versus an afterthought. It's not just something you think after, maybe I should do that. It's something which adds to the value of your building, adds to the value of the property, adds to the value of your life. And that's it. My summary. The only way to know if you have healthy indoor air condition is you test it, you monitor it, and the cost of monitoring is insignificant compared to the benefits. Thank you very much.
Yeah, thank you so much, Kai, for the presentation and joining us, and all of you who were joining us as well. For those of you who have to get going for your CEU, you're good to go. For those of you who want to stick around for a couple questions, we'd love to have you. And before we got into those questions, I just wanted to share with you, here I am monitoring my radon and indoor air quality there. Obviously humidity a little bit higher than I want it, but it's still okay. And what I really like about these monitoring systems, as Kai pointed out, is you can see the mold risk part there, right? And it shows it very low. And so obviously when you're monitoring radon, you're putting it in these systems down in the lower levels where radon's going to be bad. And that's a lot of times, like if you have, like I do, a Michigan basement, you're going to have mold and mildew issues as well in those areas the most. So I really like this idea that it's continuously monitoring humidity, continuously monitoring temperature, and it's getting that dew point, which then I believe over time gives you your mold risk, and it's checking the radon at the same time, and VOCs and other things. So and also, you had shared a little bit of power outage, and that's, what happened to me 2 years ago. We had installed a radon system and had a monitoring in place before and after, and showed that it worked very well. And then the power went out. And if you've all seen the radon systems before, they're usually, I believe I think they're level when you're looking at the system. I believe it's level. And then if they go like this, it's you've got a problem. It could be the other way around, but one or the other, it tells you if there's an issue. And so, but who's going down into their dark, dusty, spider-laced basement to go check their radon system continuously, right? And so, and it was cold outside. We weren't outside too often. And so the power had went out and tripped the breaker on the radon system. And it would have been like that for a long time. But again, my radon monitoring system's like, hey, there's a problem. And I'm like, no, that can't be true. And so go downstairs, see that the pop fan's not even on. Breaker had tripped. So it's real to have these. And so Kai, I kind of wanted to ask, it almost seems like we're talking about really 3 tiers now. We're talking about a short term, which you explain the drawbacks, cheap, but drawbacks. And I think long term really is those home inspector tests, which are great. And we want people to do those 30 days, 90 days. But isn't it really true that we're really talking about now there are 3 opportunities? There's short term, long term, and I don't know if it would be called continuous, maybe forever. I mean, is that true to say that there really are now 3 options available?
You could consider 3 options, but the middle option is the 30-90 test is really not as often practiced. Typically, what happens is 30-90-day tests by professionals are only done as a follow-up test of a short-term test after mitigation. It's really not a standard procedure that people put a professional long-term testing in place. It's an exception, really. That's why if I talk about testing, I really think about a short-term test somebody can do in 2 days. There might be a follow-up test for 30 days in some rare occasions, or a long-term test which becomes a continuous test, a test basically which continues forever if you like. So.
Right. Yeah. Continues. And so another question came in on the mitigation side. And it was a really good question about, what needs to be done based on the requirements for mitigation. And I think you really pointed out that there's no federal code, but there are probably state or local jurisdiction codes. Do you know if those codes are pretty uniform in the way one needs to mitigate, or is it pretty different depending on where you go in the country?
No, I mean, all the codes are going back to the EPA recommendations of 4 picocurie and basically considering mitigation between 2 and 4. From this level, they are very similar. However, the codes of implementation and certification and how the mitigation systems are basically validated are much different. The goal, the number is very similar,
right?
But the practice, how they're being done and how they're being quality assurance varies a lot.
Right. Yeah. And that's, why we have some of the green building programs and the EPA giving out guidance on what to do. So for those of you who are unsure, we always say follow those recommendations and you're probably going to be in line or better, right, than what might be required in your local jurisdiction. On the 4 being the action level, it's my understanding that in other countries where they use different metrics to be sure to measure radon, I see one of my radon systems, I can actually change the metrics and then the number fires way up and it shows me in the 50s or 60s in this other metric, and I panic because one time I changed it on accident. I'm like, I'm in the 60s. What's going on? Oh, I see. It's a European standard or something. But isn't it true that in other countries, perhaps Canada or Europe, maybe it's the sort of 2 is really the action level where people should take action? Do you know anything about that?
So the World Health Organization standards actually 2.7.
Yeah.
They are based on a measurement unit of becquerel per cubic meter with picocurie per liter. and it's basically a very round number, becquerel per meter, becquerel per cubic meters is 2.7. Canada uses the same World Health Organization. Also, one thing I want to notice is that Canada, in particular European countries, their buildings and regulations requirements of indoor air hazards about long-term tests. So they actually have regulations in place, similar like our Indoor Air Act, which actually stipulating annual exposure levels and not short-term test levels.
Mm-hmm. And speaking about stipulations, a question just came up. Have you heard of any talks in the US about a national uniform approach to radon requirements, I guess? And one of their concerns was the especially low-income housing projects who maybe get left out. I do know, on the note of low-income housing projects, for those projects that are following low-income housing tax credit sort of projects, most states require green certifications. And so in those rare instances where there's never enough money to help, they may be required to follow radon if they're following LEED or enterprise standards. But outside of that, many low-income projects, you know, quite frankly, might be left out in lack of a federal standard. So have you heard any rumblings of federal standards being in place?
The most I heard is about the HUD, who basically implements regulations for the 5 departments. I started with the FHA first, which includes low-income housing. The problem here is that the testing requirements are still mostly limited to short-term testing and mostly charcoal because of the availability, the cost, and also there's just not enough test capacity right now. So I want to expand this to the other departments within HUD. But there are certainly concerns about how to fund that for existing buildings, for instance, where there is no building construction budget anymore. So there is no facility management budget which are counted for testing. While it's maybe not much, $250 per test point, but if you have to test 100 test points every 2 years, it becomes a significant number of dollars, and this needs to be accounted and budgeted for. And this is where the most pushback comes, is what to do about existing buildings which never been tested, potential exposures, and are in subsidized housing and housing in tribal communities, you name it. There's a lot of discussion about how to facilitate. Everybody has the good intent, but not everybody has the ability to actually do it.
Mm-hmm. When you're talking about people who are building maybe high performance homes or doing renovations, you know, they may be making financial decisions, of course, between an energy recovery or maybe a heat recovery ventilator, though we don't recommend those. And for those of you who don't know, those are like basically ventilation systems. They're like lungs for homes, breathing in fresh air, expelling exhausted air. So they might be making a financial decision between an ERV or a radon system. Obviously, we recommend both. I have both, but you know, let's say you're trying to make that decision. And so some people, you know, there's all sorts of conversation out there about these energy recovery ventilators, as they can be, and some of them can be set up to have a positive pressure. Do you know about like how, first of all, is that true? Can a positive pressure system actively reduce radon? And you know, how much does it need to be? Do you know anything about that?
Yeah, so positive pressure systems prevent radon by simply not letting it migrate or diffuse penetrate the house by basically having a higher pressure inside the house, avoids the radon to come in. Mm-hmm. It's effective, that can work. They're not always, they have to be carefully designed and maintained. How do you maintain positive pressure now? It's easier to do that, let's say, in a basement, which is closed, versus buildings without closed lower floors, basements. I don't know the cost of them, to be honest. This is not my area, but I do know
that's
that
fine. Yeah. Well, and then on that note, then does it work backwards? Because, you know, like I look at Michigan, you know, we have a ventilation code. Many states are adding ventilation codes, and a lot of times the code starts out with the cheapest thing, right? And what does the cheapest thing end up being? It's either two things. It's either down south, it's a supply only, positive pressure, force it in through the system. But up here, it's a bath fan running all the time, putting a negative pressure on the house. Is there a chance that our ventilation code, which is meant to help our health, could be drawing in more radon?
Absolutely. If you have negative pressure systems, you actually do the opposite of good things. You're sucking it in.
Yeah.
Also
So,
to mention, I want to here in Florida, for instance, we have occasions where we have radon in buildings, not just in the ground floor. There was a case, Florida State University, where a high cancer cluster, and actually it wasn't just in the ground floor, but basically radon was emanated through the soil in the house, but then was basically being circulated by the HVAC systems, by the ventilation systems throughout the house, and everybody, or throughout the building on campus. And we're in contact with them, but it caused actually a high rate of deaths of staff who worked in these buildings for a long time at elevated floors in Florida, where usually you don't have radon problems.
Yeah. So what is it typically, obviously you think of these short-term tests, sometimes the health counties, I've had instances where they give them away if you're doing like a program, otherwise we've seen like 10, 15 bucks or whatever. I think you were showing on that chart sort of your cost, right, of taking action versus not taking action. But what was it again that these sort of what I would call continuous air quality monitoring systems with radon?
Well, they're now available from about $100, some of them below $100 to $250, $350. Depends a little bit what complexity you want to have, something that is connected to Wi-Fi, but it's not, something that measures just radon, something that measures more. But I would say the average cost of a indoor air quality motor with radon, Wi-Fi connected, you can say $200 to $250.
Yeah. Do you know to get in a lot of these systems to get that data or to maintain or store that data, if there are typically ongoing costs for that, or is that something that's always available?
No, it's typically part of the acquisition cost of the device, that you get free unlimited data. I don't know anybody who charges for the data at this point in time. Maybe when storage providers will charge more money, this will come. I also want to mention that with the permission of the users of these devices, which is on the mobile app, we have the ability to share this data, only with permission, of course. Share this data anonymously with CDC to build out the new maps to help radon awareness, and basically also get a little bit over this mystique that just because your neighbor doesn't have radon doesn't mean you're safe either. It gives a lot of sophisticated data every year to improve our knowledge and awareness.
Yeah, that's a great point. And you had mentioned CDC and not EPA. Is EPA handing this responsibility off to the CDC, or are they coordinating with each other?
Well, right now the CDC has what's called an environmental monitoring project, and radon is one of the parameters. It's all handled by the CDC. They have very strict policies in place how they gather data, but we're basically helping them to supply data to make better decisions and updating the EPA maps.
Yeah. I had heard, saw some chatter with the unfortunate and sad incident recently in Turkey with the earthquake, that perhaps there were radon spikes in measurement equipment in the area that went up significantly right before the earthquake had hit. Is there any truth to that? Is there a possible chance we can get more earthquake notification based on monitoring radon? Have you seen anything like that?
Not lately. I heard about it, but it's not a focus of our area.
Yeah, just interesting. I thought I'd ask since you were here. So, and then I think what really intrigued me, and we talked about this before as a last question, is that study you're doing in Georgia with the university there. So it sounds like maybe there could be some future conversations about how to, and this is always the quandary with new construction, right? It's how does someone building new know if there's going to be a problem and whether they should install the system. And we have these conversations when we're doing design consulting. So of course, our default answer is put the passive system in anyway, and also it could change in the future. But let's say someone's trying to make that decision outside of the EPA radon maps. It sounds like there might be some studies coming out as assessing a empty site before it's built.
Yeah. So this is what Georgia State does. Now I have I think 3 or 4 test sites in different 2 in the Atlanta, Georgia area, and one
Yeah.
outside. So also working with Tennessee University now to expand it. So the idea really is to get an assessment of the potential risk and exposure before you ever start building anything. To give you really not so much if you want to do a passive system, but more like how much your risk is to design your system properly.
Right. Yeah. Well, Kai, we really appreciate your time and sticking around. And, where can people go to either contact you or learn more if they want to reach out?
Well, please feel free to go to sunradon.com, our webpage, and there are links to contact us or support@sunradon.com or sales@sunradon.com. We're happy to answer any question we can. We are not certified indoor air quality specialists, but we are in this industry for 30 years and have quite a lot of experience to share, and we're willing to share.
Yeah. Well, Kai, thank you so much for your time. Thank you all for joining us. We'll catch you all on our next event next week. So thank you so much. Bye.
Thank you very much.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.